So for dividing rational expressions, the example I chose is it's a simple one in the sense that it's just one term, right? I only have one x adding one number. I didn't do parentheses because I don't have multiplication. I just wanted to show how to do it. Yeah. And then here, one important thing is the denominator cannot be equal to 0 for all the fractions that you write out. So one fraction here on the left is x plus 2 divided by x minus 1. It's called a rational expression because it's a polynomial divided by a polynomial, right? These are not exactly like I have the x here, so it's not actually just a number, right? It's a variable plus 2. And then the denominator is x minus 1, so x minus 1 cannot be 0, so x cannot be equal to 1. I can never evaluate the value x equals to 1 in this expression. And on the second one, we have 3x plus 6 divided by x plus 1. So again, x plus 1 can never be 0. So x cannot be minus 1 either. So there are two values that x cannot be. X cannot be minus 1, it cannot be 1. So when they mention domain, which is something I forgot to type, domain is all the numbers you want except 1 and negative 1. And then to divide by something, here's what I put in the blue square, is that dividing by a fraction is the same as multiplying by its flip. So I flipped the 3x plus 6 and the x plus 1. And so now it's x plus 2 divided by x minus 1 multiplied by x plus 1 divided by 3x plus 6. And then when we multiply fractions, it's actually the top multiplies the top divided by the bottom multiplied by the bottom. But then here, the 3x plus 6, I decided to take the 3 out. 3x is 3 times x, and 6 is 3 times 2, right? So I factored the 6 and made it into 3 times 2, and then put the 3 out. Take the 3 out, so then it becomes 3 times x plus 2 inside the parentheses. Did everybody follow that? I need people to understand that dividing by a fraction is multiplying by its flip. So if you guys have paper and pencil next to you, which is a good recommendation for any math problem, I want you to write a big 1 and then divide it by, as in a fraction, like draw a horizontal line under the 1 and write half under it, like 1 divided by 2, smaller. Yeah, so you want to have 1 divided by half. But we know what 1 divided by half is, right? Like how many halves does a 1 have? A 1 has 2 halves. Is that okay? So 1 divided by half is 2. So what did I do? I just flipped the half. So 1 divided by 2 is equal to 2.
Where I'm getting stuck is specifically the second row, where actually the third row before the first blue arrow, where you've broken down 3x plus 6 to 3 parentheses x plus 2. I couldn't get my brain to go forward on that no matter how hard I tried.
Yeah, I understand the flipping from like regular fractions, but I don't know how 3x plus 6 gets turned into 3x plus 2. Like, where did the 2 come from? Like, that part is just a bit. Yeah.
Okay, Ben, can you go some slides now? There's one that I have some images called distributive rule. The distributive rule, you know how to expand a parenthesis, right? Do you know that when it's numbers? Like, do you see that on the left side? 2 times 4 plus 3 inside the parenthesis. Does everybody see that? On the left? It's equal to 2 times 4 plus 2 times 3. That's what we call the distributive rule, because we are distributing the multiplication inside the parenthesis. And that becomes 2 times 4, which is 8, plus 2 times 3, which is 6. So it gives you 14, which is the same as 2 times 7, right? So either way of course, you give the same number, right? If you do the sum first and then you multiply by 2, it works the same way. If you do the distribution first, then add the products. That gives you 8 plus 6, which is also 14. Right? Is that okay? Is everybody okay? So now just instead of 4, imagine that the number 4 is now an x. So you have 2 times x plus 3 equals 2 times x plus 2 times 3. What I did in the original slide is going from the right side back to the left. Do you see that? Because here on the second line, right, we have 3x plus 6. 6 is 3 times 2. So both terms have a 3. So I'm just what we call factoring it out and put in a parenthesis around x plus 2. Now, you don't have to believe me. Try to expand that. Try to multiply out 3 times parenthesis x plus 2. How much do you get? You have to follow the rule that I just showed, right? You have to do 3 times the first guy, which is x, plus 3 times the second guy, which is 2.
So so the answer would be 3x plus 6. So it's the same thing, just written differently.
Yes.
Okay, so because I rewrote 3x plus 6 the way you showed the distributive rule. And the answer is, it would be then 3 times x is 3x, 3 times 2 is 6. So then it would be 3x plus 2, or 3x plus 6.
Right.
Okay.
So the other slide shows you how to go from the third row back to the second row.
Okay.
So what we are doing here is just reversing the process.
Mm-hmm. And then the x plus 2 and the x plus 2 can cancel each other out.
Right. Now they can cancel, right?
Okay. It's like reverse distributing. It's, to me, it's dividing. It's like splitting the x apart from the, I'm looking at a different problem right now, but it's splitting. It's, I'm going to look at this one. I'm looking at my notes. You're not even dividing, but it's like you're splitting that x away from the 3 and then taking that same distribution over to the 6 and splitting that so that it's down to 2.
So that we make it smaller.
Dividing.
Okay.
Mm-hmm.
Yeah, because this is how we would factor in, like with the x's, right? Before I was talking about factoring with just numbers, but when we have x, then we try to keep similar terms, expressions with the x as much as possible so that I could cancel with the x plus 2 in the numerator.
Okay. So I thought it was like, I'm like, where is this 2 coming from? Actually, we're still writing 3x plus 6. It's just rewritten in a different form.
Right.
It's almost broken down,
6,
like
yeah.
any segment divided, and then you're able to much easier simplify the problems in front of you because x plus 2 and x plus 2. Yeah, I'll probably need to do some more practice on these and see some more examples. But that is the exact point where I was getting lost, like right there. And I was like, what is happening?
So one thing that I
really
noticed is that students tend to forget, like from the bottom here, 3 parentheses, x plus 2 close parentheses. When I ask people to expand, like write it all out, multiply everything out, they'll just tell me 3x plus 2 instead of saying plus 6. And that's wrong. Because you have if you have lots of things inside the parentheses, you need to multiply the 3 by every single one of them. You can't just do the first one and forget the rest. If you're going to remove the parentheses, when we remove the parentheses, we need to multiply the 3 by everybody inside the parentheses.
Yeah, when you had me write it out, that's when it clicked and I saw 3x plus 6 and I was like, oh, it's still here. It just looks different. Okay, that was very helpful.